Hello everyone, and thanks for attending this virtual session. My name is Jordi Mercenoguer. The focus of my talk today is on evaluating computational models generated from multiple micro-CT scans with different parameters. We will identify the most feasible scan combination for practical yet accurate biomechanical simulations for zebrafish conductive hearing system. The Vivarium apparatus works as middle ear in the zebrafish conductive hearing system. It enhances hearing in optophysian fishes and conducts sound vibrations through coupling of the gas bladder and inner ear. In zebrafish, is well developed with 4 pairs of ossicles and present diverse morphotypes in laboratory settings, and thus provide a great platform to understand the conductive hearing system of vertebrates. In this work, we firstly segmented and created 3D models from CT scan image stacks at 464 micrometers, 505, 930, and 1308 micrometers voxel resolutions. And then we analyzed basic morphological characters, volume and surface of the digital model to check for differences. We used geometric morphometrics to quantify intermodal shape differences. And finally, we performed finite element model and harmonic analysis to simulate auditory signal vibrations. As I told, the aim of this project are twofold. Evaluate models generated from multiple micro-CT scans with different parameters to find the most feasible scan combination for practical yet accurate image for biomechanical simulations. And two, hypothesize practical scan parameter combinations for similar sized structures in zebrafish or the same structure in other small animal models. A single specimen of the same adult zebrafish was scanned using 4 different parameters and using 2 different micro-CT scanners. The X-ray-designed scanner uses proprietary interchangeable focusing optics that allows users to locate and scan small subregions within the specimen. This is followed by seamless digital stitching of multiple scanned subregions. On the other hand, Bruker SkyScan scanner is more cost-effective and time-efficient, using lower radiation doses and producing lower resolution scans. We compute also the resolution factor as the length of the Weberian ossicles chain, which is in this case 259 millimeters, divided by voxel size. This parameter can be useful for further comparison and describes the number of slices needed to cover the body of the Weberian apparatus according to the resolution of the CT scan. Then we performed a geometric morphometric analysis. We collected 41 landmarks on the surface of the Weberian apparatus of these 4 different models. Landmarks were analyzed using the GeoMorph-R package, and we performed a Procrustes superimposition to remove differences due to the scale, translation, and rotation. The FEA model is based in the descriptions of McNeil Alexander, and will be published soon with in-depth detail of the model. The Weberian ossicles, Tripus, Intercalarium, Colostrum, and Scaphium are connected via ligaments and fixed via cartilaginous connections. Ligaments 1, 2, 3, and 4 are included as spring elements, and the locations of the boundary conditions, fixed displacements, and the joints between ossicles and the spine, as leaf spring and spherical joints, are displayed in the figure. The swim bladder applies a pressure in the model, which will be transmitted along it, and it is also included in the model, as you can see in the figure. So, when we have the geometry of the model digitalized, the material properties defined, the finite element mesh created, and also the boundary conditions and the forces applied in the model, then we proceed to solve the model. In this case, we first solve a model analysis, and then it allows us to get the results of the harmonic response. We are preparing the manuscript with further details, and in this manuscript, all the results of our FEA model are validated according to the results published by Finneran and Hastings in an experimental device. At this point, the question we want to answer today is if our morphological and biomechanical models are affected by resolution of CT scans. To do this, we first observe the original ossicles from dissection and the visualization of CT image, pointing out that the larger the structure, the less the difference between models. Model 464 has a complete Weberian apparatus with all the ossicle details, whereas the other three models show more or less incompleteness in the claustrum and the foramen at the superior process of the tripus. On the other hand, the overall shape of the tripus exhibits no visual differences across models. Considering that model 464 is the most accurate model, we'll use it as a reference point for comparison with the other models. Moreover, we computed the basic morphological parameters of the model, volume and surface from the four different models. In quantitative comparison, there are slight differences between the models in the volume and surface area of each ossicle. There is a general trend towards smaller values in models built from higher resolution data. The most apparent differences can be found in the scaphium. Regions of the scaphium are incomplete in models 505 and 1308. Procristi's distance suggests that despite the good voxel resolution model 505 has, it is the least accurate model. Also, loadings shows the landmarks that varies the most among the four models are mostly located in the tip of the intercalarium where the ligaments are attached and in the contact areas between the scaphium and the claustrum. This is the place where we are assuming that the vibration is conducted. So let's see how it affects the FEA model. We also observed how the voxel resolution affects the FEA outputs of the hearing system. Given the modal analysis is mathematically mandatory before the harmonic analysis, it was performed first. The table reports the first 6 modes of vibration for each model obtained in the modal analysis. There are only minor differences in the first 2 modes among all the models, but substantial differences between models in mode 3, 4, 5, and 6. It is worth to mention that our previous work stated that only the 3 first modes are important for studying the hearing response. So let's see how they affect the harmonic analysis. Harmonic analysis results characterize the response of the Weberian ossicles to the sound pressure exerted by the gas bladder. The results of the harmonic analysis in the 4 different models shown that the amplitude of the vibration of the scaphium in model 505 is unexpectedly and abnormally low. Model 930 and 138 generates a frequency at resonance and peak amplitude close to model 464 in tripus and diverge later when vibration pass on the intercalarium and scaphium. We can see also that the tripus vibrations are nearly in phase in all of the models, but intercalarium vibrations of model 13.8 are out of phase, whereas the scaphium vibrations of model 505 are out of phase comparing to the rest. Using the highest fidelity model 464 as a reference, we conclude that the overall behavior of model 930 in both modal analysis and harmonic analysis is closest to model 464 out of the 3 remaining models. At this point, we can say that morphological and biomechanical differences are evident from comparative analysis of 4 zebrafish Weberian apparatus models with varying scanning resolutions. The differences in resolution and quality of the CT substantially affect the segmentation and reconstruction process of the 3D models of the ossicles and the subsequent analysis. We conclude that scan voxel resolution and contrast variations in CT image are a key factor influencing the results obtained in biomechanical simulations of delicate and minute structures. Similar resolution considerations are recommended for future image-based analysis of Weberian apparatus, as well as similarly sized organ or structure systems in zebrafish. So, thanks for attending this talk. I want to thank all the people that helped us to perform this research. If you have further questions, you want to contact me, you can contact me by Twitter, sending me an email, or in the live discussion event organized by the conference.